Okay, so in this video I wanted to talk about gravity and gravitational fields, and potential energy and kinetic energy. So when you have a gravitational field, that's basically just an object with a gravity, right? So let's say you're walking in the park and you see a ball, and the ball's like this. We're just going to ignore friction, by the way, for this example. But the ball is in midair at the moment. It is 2 meters high. Let's say it's 1 kilogram. So it's 1 kilogram. And we know that gravity is equal to 9.8 meters per second squared. That just means that it's an acceleration of 9.8 meters downwards. Yeah, so that's what gravity is. It's just an acceleration downwards of 9.8 meters per second squared. Okay, so now we want to find out what the potential energy of this ball is. And we can do that by figuring out how much energy the ball would, how much work the ball would output if it were to drop that 2 meters. If it were to drop that 2 meters. So we can find out the potential energy by finding out how much work it could cause. That's why it's called potential energy. Okay, so we can solve for potential energy by just saying mass times gravity, which gravity is acceleration, right? So mass times acceleration is force. So mass times gravity equals force. And then we know that force, I'm just going to write F times distance, let's write D for that, equals work, so just W. So, yeah, so let's just calculate for force first. So we know it's going to be 9.8 meters per second squared, which again is just an acceleration downwards. That's why we can use it in that equation for force. But we can do 9.8 meters per second squared, and we can multiply it by 1 kilogram, right? Because that's the mass. So it's just right here, 9.8 meters per second squared times times 1 kilogram. Okay, equals 9.8. Oh, maybe I'll just write it. Okay. Geez. I think I'll just write it down here. So 9.8. 9.8 newtons. That's how much force we have. Okay. So newtons is basically just the unit for force. Okay. So now that we have force, we know force times distance equals work. Okay. So we're just going to multiply by 2, and we get that our work is 19.6 joules. So the potential energy of this ball currently is 19.6 joules. Okay, so now for the second part of our question, we're going to talk about kinetic energy. Okay, so let's just redraw the ball, and again, it's 2 meters above the ground, and so that's the ground, and it is 19.6 joules of potential energy. Okay, so let's say this ball, all of a sudden it drops. This 1 kilogram ball, all of a sudden it drops. So let's just write this all out. I mean, squared. Okay. Let's say this ball drops, and then it dropped. Let's just say that the work it outputted was equal to 9.8 joules. So the amount of work that was outputted was 9.8 joules when it dropped. So I'll write that now. 9.8 joules. Okay, so it drops 9.8 joules. That's how much energy it output, how much work it output when it dropped. Okay, and now we want to find out how much potential energy is left, right? Okay, so we can basically say that we can find out how much potential energy is left because the total amount of energy we had before, we can just subtract how much energy we lost. And how much energy we lost is 9.8 joules, because that's how much energy went into the dropping, right? So we lost energy when it dropped. So we can just find out the remaining energy of the potential, right? So 19.6 joules minus 9.8 joules, right? And that is going to be equal to 9.8 joules. So the ball in its state now has 9.8 joules of potential energy. Okay. So potential, and that's because potential plus kinetic equals the total amount of energy. So the kinetic energy was 9.8 joules because when it dropped, that's how much energy was done, right? And the potential energy is 9.8 joules because that's how much energy there is now. And there was 19.6 joules the ball had at the very beginning of the video. Thank you.